Alright guys, it's Mr. Middleton. Today we're going to talk about segments, rays, parallel lines, and planes. Um, Again, we're still in the building blocks of geometry, finding out what different figures are, how to refer to them, how to label them, how to write them. We're add a little bit more and build on our points, lines, and planes that we worked on previously. By the end of this video, I would hope that you should be able to identify segments and rays, name them, write them, refer to them correctly, and then that you can recognize parallel lines and also parallel planes. Okay. So again, we'll start with some definitions and some examples of how to name them. First definition we'll work with is segment. Okay, so looking at this picture, it might just look like a line. The difference between a segment, though, and a line is that a line continues on forever, where a segment has two endpoints. We know exactly where a segment ends. Okay, and so segment's part of a line consisting of two endpoints and all the points in between them. A, B, segment A, B. Okay. To write or refer to the segment, we would write it as A, B. This means segment A, B. Notice there's a difference between how we write segment and line. When we wrote a line, we had to write arrows over top to indicate that it would continue on forever. But now that we're talking about a segment, we don't have to do that. And just like a line, we could also call this segment BA. Okay, these are the same segment whether I say A to B or B to A. The points, the line, or the line segment doesn't change. It's still this segment. Okay, so this is the same thing. So if I were to ask you to name this segment, either way works. It wouldn't have matter which order you did it. Okay, segment and ray. Okay, the easiest way for me to think of this or remember this is like a ray of sunshine. Okay, it has one endpoint. You know it comes from the sun and it continues on forever. Okay, so a ray has one endpoint and continues on forever. So we're just looking at this line XY for right now. But if I said ray XY, that would mean something different than line XY. Ray XY, when you name a ray, you always start with the endpoint. Okay? So if I said ray XY, what I would mean is that this ray starting at X and continuing on forever in Y's direction. Okay? And to write that down, I'll call it ray XY. Notice again how we changed our line over top of our letters for our line, or name for our line, because I want everybody to know that this is a ray XY. Okay, if I said ray YX, okay, starting again with the endpoint, excuse me, and it's going forever in X's direction. Okay, now this is tricky. Well, not really tricky, but this is the rule. If I say ray YX starts at Y and continues on forever in X's direction, I'm still going to write it like YX. And notice my ray still continues this way. When I'm referring to it, my ray will always look to the right. It will always go to the right. Okay, no matter which direction it actually goes in real life. Okay? So segments, rays, and then last one, opposite rays. Opposite rays are just two collinear rays with the same endpoint. Okay, so here we have a set of opposite rays, ray RS and ray RQ. Okay, notice they both start with R. Okay, remember we always start with our endpoint. RQ. Okay, and what opposite rays do? They're just two rays that make a straight line. They form a straight line. My paper gets really crooked. Okay. Alright, remember to pause this if you need to in order to write all the definitions down and get everything you need written. Okay. Alright, so looking at an example, and again you can pause this to give it an attempt before I do it. It says name the segments and rays in the figure below. So the segments I see this segment LP. I see this segment PQ. and I see this segment LQ. Again, I don't need to say QP and PL and the other direction because it's the same segments. Okay, now it says name the rays. We have ray LP. Remember, that means that it starts at L and continues on forever in P's direction. Okay, so another way to name ray LP is to name it ray LQ. Okay, LP and LQ in this case would be the same thing. It goes in P's direction, same as going in Q's direction. So I only need to write one of those. Okay, ray PQ. Okay, from here to here, we could call it ray QP or QL. Okay, so we can call it ray QP or QL. That will be the same thing. And then we could call it ray PL. Okay, ray PL goes from P in L's direction. Okay, so that's us referring to all the different segments and rays in that small little diagram, simple diagram seems like. Okay, moving on from there, let's talk about parallel lines and skew lines. Parallel lines, in algebra you might have thought of them as two lines having the same slope, which is still true if we put it on a coordinate plane, but as far as just thinking about parallel lines in geometry, it'd probably be more beneficial, at least for right now, to think of parallel lines as coplanar lines that don't intersect. Okay, two lines that are on the same plane that don't touch. Okay, so and that's any line really that has the same slope, but it's still just a little bit different thinking in 3D. And then skew lines. Skew lines are non-coplanar and therefore they don't touch. So actually have something drawn down here that we can look to refer to that. So looking at this cube, I have parallel lines here. DC is parallel to AB. Okay, notice they're at the top of that cube. They're on the same, they're both on the top, but as they go and they continue on, they don't touch, they don't intersect. Okay, and those two lines are parallel. DC and AC are parallel lines. Okay. And then sometimes you see parallel as just two straight lines. Okay, that means parallel. Now, AE and DC are not parallel. Notice AE goes up down here. Okay, if you're thinking of this as a three-dimensional figure, DC would be back here, would never touch it. Okay, but these definitely aren't parallel, but they don't intersect. The reason they don't intersect is because they're skew. Okay, AE and DC are skew. Alright, so just an example of both of those terms. And then parallel planes are just planes that don't intersect. Okay, so just looking at this cube, you can kind of think of the planes that don't intersect as like the top of the cube and the bottom of the cube. And remember, when we name a plane, we name three non-collinear points, so I could say that plane ADC, say plane ADC and plane, because ADC is the top, and plane EHG are parallel planes. Okay. Alright, so those are the terms that you should be familiar with. Take a second, make sure you have this all down. Rewind, go back over any parts that you need to, and then we'll work with these tomorrow.